Okay, we're going to do another day of 7-4, just a few more examples. This one has the square root of 4x squared plus 16 in it, so that's a squared plus u squared, or u squared plus a squared integral. And as we've seen, that's the version of the triangle with the square root on the hypotenuse, and then the a and the u are the two legs. I'm going to give you the the rules, which triangle to use, and what to make the square root and what to make u. So basically, everything over here on the right, I'm going to give you when I'm asking you to work these on a quiz or a test. So all you'll need to do then is figure out what our u is equal to and what our square root is equal to. If u equals a tangent theta, then the substitution we're going to use is that 2x equals 4 tangent theta. And our square root of 4x squared plus 16 is equal to 4 secant theta. And if I think one of the most intimidating part of these is knowing which triangle to use and which substitutions to make. So if I give you all of this, then that's going to make that process a lot easier. Okay, so let's use that info to substitute out the x's and in the thetas. This particular integral has a 1 on top. There's no substitution necessary there. It has an x on the bottom. And I don't know what x equals, but I know that 2x is 4 tan theta. So based on this, x would be 2 tan theta. So that's what's going to go first on the bottom, 2 tan theta. And then on the bottom is my square root, which I know now is equal to 4 secant theta. And then the only thing left to sub out is dx. And I don't know what dx is yet, but I know if x is 2 tan theta, then dx will be 2 secant squared theta. I'm kind of working upwards here, but just making a list over on the right of all the x theta relationships that I can come up with. So 2 secant squared theta goes in for dx. So I had 3 parts to get out, and I put them all in now into theta world. All right, so now we can work on making this look nicer and integrating it. Let's see, I've got a 2 and a 2 that I can eliminate from top and bottom. Then I have a secant on the bottom and 2 secants on the top. So I can simplify this a little bit and have just 1 secant on the top. And I've got a 4 left and a tangent left on the bottom. I'm going to go ahead and bring the 4 out, not worry about it. And I end up just trying to integrate secant over tangent. And secant over tangent, that's actually going to fit nicely into one of our rules. Secant is 1 over cosine, and tangent is cosine, tangent is sine over cosine. But, again, that's sine over cosine should be on the bottom. So I've got secant on top and sine over cosine on the bottom. And dividing by sine over cosine is the same as multiplying by cosine over sine. I can pull that up and flip it over. Then I can cancel, get 1 over sine, which is cosecant. Okay, so long story short, this integral is 1/4 the integral of cosecant theta d theta. If I were a responsible math teacher, I would know all my integrals, but I'm not, so I'd have to flip to the front of my book and realize that the integral of cosecant is negative natural log of the absolute value of cosecant plus cotangent. I was just joking. I know every integral rule and every trig identity by heart, naturally. Um, and then I've got my plus c. Okay, so I've integrated, excuse me, I've subbed out. I've found something I could integrate. It actually worked nicely into one of our regular integral of trig formulas. And now I need to sub back out. So basically what's left to do is to figure out what's the cosecant and what's the cotangent of theta, all based on my original triangle. So I'm going to scroll back up and figure out what cosecant and cotangent are. Cotangent of theta, it's going to kind of add some new notes over here in green. I'm looking for what's cotangent of theta and what's cosecant of theta. The cotangent of theta is tan flipped over. And if tan is opposite over adjacent, then cotan would be adjacent over opposite, which would be 4 over 2x, or 2 over x. And cosecant is the opposite of sine. Since sine is opposite over hypotenuse, cosecant will be hypotenuse over opposite. So that would be our square root 4x squared plus 16 over the opposite of 2x. If you factor out a 4 from the 4x squared and the 16, and then you pull that 4 outside of the square root and cancel it with a 2 on the bottom, the cosecant should simplify all the way down to this, the square root of x squared plus 4. Okay, so those two items right there, cotangent being 2 over x, and cosecant being the square root of x squared plus 4 over x, get simply subbed in to my almost final answer. I'll put the negative in front of my 1/4 just to make it look a little nicer. Cosecant is the square root of x squared plus 4 over x. Cotangent is 2 over x. So those will add together nicely. We'll play nice, and we end up with the square root of x squared plus 4 plus 2 all over x plus c. Okay, so another one, and I think with that being 5 or 6 examples that we've done on videos or in class, hopefully you're starting to get the idea. We will do a few more of these in class, but just to review again, we have an integral with a square root that we have no other way to deal with. We use this triangle setup to get out of x's into thetas, creating an integral that we can deal with, in this case the integral of cosecant, which is one we can do, integrate it, and then use the triangle to go backwards into x land, creating this final answer. Okay, so we'll do another 1 or 2 in class and then maybe move on to the next section, but for now this is all you need to do. So bring these notes to class. I'll see you on Wednesday. Young out.